start from this introduction lecture. So today we will be covering history, facts, features, and new data types in C++. Okay, let's start with the history of C++. So Baron Zorstrup has started making C++ in 1979. He started with C plus classes. So there was C language. On top of that, he has created some classes. So classes concept had introduced in 1979. After that, in 1983, he completely given the first model of C++. C++ means the plus plus operator, which tells that it is a superset of C. Okay, that is about a little history about it. So features of C++ which we have taken right now is C++ is a middle level language. So the middle level language means it can form the upper section, like we can produce some very high scalable software with C++, like gamings, okay, related to cameras and all. So where the data is heavy and the lots of code is required, lots of lines of code is required, it's very scalable also. In that section, C++ we can use, as well as you can see in the embedded platforms also. Today the C++ is coming. So the so the lower level also it can access, like registers of CPUs, okay, controller boards, all that of thing the C++ is coming. C++ supports OOPS, object-oriented programming methodology. So what is this? This is like we have procedural programming, we have object-oriented programming, so structural programming. So there is a way of writing a program. Okay, so procedural programming means writing the program in the form of a function. So we transfer the data from function to function. Whereas in the OOPS concept, object-oriented programming, we create object and we pass the data from object to object. Okay, some new features are also introduced in C++, which is generic programming. What is the meaning of generic programming? There is a principle called try, don't repeat yourself. Okay, suppose you are performing addition, subtraction, multiplication, all these things. Suppose you are having a function which adds two numbers, two integer number. C++ with the help of templates, with the help of STL libraries, gives you an opportunity that you can, with the same function definition, you can add two floats value also and two string values also. Okay.
Okay.
Let compare the difference between C and C++. C++ is a superset of C language. C++ can use C software libraries. What this means is, for example, printf, scanf, whatever methodology you're using in C++, like using pointers, function pointers, arrays, whatever sort of softwares you are using, you can use in C++ also. C++ compiles it the same way. What is you can use the libraries also. Libraries means predefined functions. Some of the predefined functions are printf, scanf. So if you want to print something on the screen, you can use in C++ also, you can use printf. For that you need to include this header file of that that printf and scanf, stdio.h. Okay, so now there is this new feature, which is top-down approach of programming and bottom-up approach of programming. You have an idea about top-down approach and bottom-up approach?
Can you please explain me?
Okay. So what happened in the... One second. So if I open Paint... Okay. So mainly what we do, we have this main first. Okay. Main program, main function we have. Okay. Inside this function, we write our thing. Okay. So for example, we written this add. Okay, I'll use text format. Suppose in this main we have add function. Okay, so first what we are making is, we are making main. I will just increase the size of it, as you can see. So first we are making a main. Okay.
Okay.
And then we are thinking what we can do in this main. Suppose we want to make a calculator, then we will add. Okay. And
For the function.
this,
Okay.
yeah. So what we are doing is we are making the top function first, then the sub functions. Add also can have, for example, here we have add. Okay. In add also there can be many adds. Adds of a string function will be there, which adds two strings. Okay. Integer function will be there, which add
That's
two.
two integers.
Okay. Float function will be there. Okay, so what you will do, you will make this main first, then you made this end first, add first, then a string, then you will go to integer and all. So the flow will be from main to this all of them. But in C++, we do first, we will try to make add function. First, we try to make an integer addition. Okay, so we'll write the integer function first. Then we will write the add function. Then we will write integer, float. Okay, then we will write the add and then we will write the main function. Okay, why we do that? Why we write simple from top to down in C and from bottom to top in C++ is because we have something called as concrete. We have a concrete class and an abstract class. Okay, so what these are, you will be learning when we are dealing with the inheritance and other methodology. So what is inheritance? How we inherit the child class, base class? It is that concept. At that time, you will understand. Okay, that is the reason why we have uses the bottom to top approach. So understanding right now, you can just understand from the main we are going towards the end result and towards the base classes. Whereas in C++ from the base classes we are going towards the top classes
Of
or
classes.
top functions. Is it clear?
Yeah, it's clear.
Okay. Sorry, I've written it wrong a little. C adopt procedural programming, whereas C++ adopt procedural as object-oriented programming. The difference is the same. I mean, function to function. C++ can have function to function qualities as well as plus object-oriented part.
Object to.
Okay, so there is something, a new type of thing has come in C++, what is called reference variable. Okay, so what is a reference variable? Reference variable act as an alternate name for the existing variable. Okay, so for example, if we jump to this show you the programming part. So I've created a folder called reference, so I can just, okay, so suppose I've created a class called one.cpp. I'm using nano operator and I'm writing this into a Linux environment. Okay, the first thing we need to include in our CPP file is this IO stream, input output stream. Okay, then we are using this using
Namespaces.
Okay, I will be covering this namespaces today only. STD. Okay, then we have int main. Okay, let's see the syntax of it. What the syntax is. Okay, syntax says the data type, the reference variable, and the variable name. So for this, first we require a variable name. Okay, we'll create a variable first. So let's take an integer variable. Integer variable is variable 1. Okay, and we assigned it to value 10. Okay, now
Okay.
according to the syntax, we come back to the structure. We should have a data type. It should be same as this data type. So we will have a data type which is an integer. Now next, what is saying? It is saying data type means int name of then a reference operator, and operator we mostly say, and operator, and we will it a name. We will reference one, ref1, and we equate it with variable variable one. So what it is holding? It is holding the address of variable one,
Variable one.
but it doesn't create a memory inside the program. For example,
Oh,
if we do it with this star,
yeah.
int star ptr, and we
It's
will
like
give something
it's
like
it's
variable
like
one.
a point. It's like a
It is
pointer.
it is like a pointer, but it won't create a memory inside.
Memory. Yes. Yes.
It,
Yes. Yes.
so it cannot point to any other variable now. It is one set. See, I will show you the difference between pointer and this, but first let us print it. Okay.
Sure. Sure.
So
Sure. No problem.
see out, and we will say R1. Okay, and we will say
And then
handle. Handle is a manipulator.
man. Okay.
Okay, and we will have use int. So then we need to return.
Done. Zero, nice.
Okay. So if we just control C, yes,
Yes.
then we'll write gcc 1.cpp
Maybe.
hyphen o 1. Okay, we have compiled. Let's see. We have an executable file known as 1. Now we see. Now it is coming 10. Let's do some more operation into it. Okay. So what we will do? We will change the value of variable after this. Okay.
Yeah,
So it
this
is-
variable 10 stored in reference 1.
Yes. Now we are changing it, and now we are printing it. If it is pointing to this one, then it will be reappearing. The value will be changed.
Yes.
Okay. Run again the same thing. /1. See, now you can see it is coming like that.
Yes.
Now if you want to see, we can access through the reference variable also. Ref1. Okay, now we'll put it as 20, and again we will have, instead of this, we'll try to print var1. Okay, yes, /1.
Okay.
See, you can see that now 10, 15 and 20 is coming. So it means that they are sharing a common address point. Let's see some other see, there are some properties. Reference variable do not create a separate memory.
Okay.
Okay, reference variable must be initialized when it's created.
Okay.
So the point is, you should always, for example, here I have created this, where it is, see, here I have created, and here only I have given the value to it. So it should be in the same way.
Initialized. When it's created, that
Then
initialized.
yes. Let's see some more
Okay.
properties of this one. Okay, reference to a pointer is possible. See,
Okay.
now how many type of variable we have till now? If you can go over here. Okay, so we have a reference variable, we
Okay.
have a normal variable. Now we'll take an pointer also. Okay, let's take another variable also. Int variable 2. Okay, and let's put it as 50. Okay, what we will do, we'll take this variable.
Okay. And variable 2. Ampersand. Okay.
Okay, now we'll
Here it
we're
here
not
it's
printing.
created a memory location.
Yes, yes. Now you can see we have this pointer variable 2. Now we want to point this with another uh, reference variable, but we cannot do like this. For example, if we create a reference variable 2 and we try to equate it with this, with pointer, ptr. Okay,
Yeah.
this is not right. This is, we cannot do that like this way. The syntax of this will be something like this. You created a pointer variable. Okay, now you need to
Yeah.
have these two operators. Pointer also you needed, and this also you needed.
Okay.
Okay.
Got
So
it.
what we need to do right now is
So
where
to
we
like this one is like a star pointer
yes, yes, yes,
int.
yes. So we have this one.
Yeah.
Okay. So now we
Yeah.
need to print it also, right? So how we will going to print it? We'll use the cout, and
Out.
inside the cout, I will write printing reference to
Pointer.
pointer. Okay, inverted commas close. Now we need to use a star. Star,
A PTR.
not
Star
ptr.
R and
Ref,
rep.
ref 2 and then create this one. Compile dot slash. Now we are able to print 50.
Yes.
Okay. Now let's see some more utility of this reference variable. Okay. Pointer to reference is not allowed because a reference has no separate memory. And what a pointer holds? Pointer holds a memory. So we
Yes.
cannot assign a reference to a pointer.
Yeah.
Okay. So now, as you have seen that we can assign a pointer to an array, correct? In the same way, we can assign a array to a reference also. Okay, so how it is going to look? Suppose a syntax is something like this. So this is uh, small brackets are used to bind. Bind means to hold all these values. Okay, and ampersand is used to reference.
Reference.
Okay. Or you can say this subscript operator has more precedency. If you can see, if you have a pointer understanding, so if you write star ptr of 5, okay, it will create a pointers of 5, a 5 array of 5 pointers. Whereas if you write in the bracket, it will create a pointer which is referring to an array. In the same way, we have a reference variable which is pointing to an integer of 5 element.
Teacher of yes.
Okay, so let's try this syntax as well. Copy it from here. Okay, so we'll try to print this. We'll have a for loop and j equals to 0, j is less than
Less than
5, j
J
plus
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 print is your
cout j, and we'll have a space, and then we'll print what? J space print ref
rep.
indexing. J plus plus. Sorry, J plus plus. I tried. And del. Okay.
Okay.
Control X. Yes. Dot slash 1. C.
Okay. Printing reference to pointer to 0, 1, 1, 2, 220, 3, 4, 4, 4, 5.
Okay. So what we have changed?
Index
We have
of
changed the second one.
changing
So we have
index
changed the
number.
second to 20, and index's first value it will having it will have 1 at the first value. Sorry, 0 value it has
Index
1.
0 value. Yeah.
Yeah, index 2 will
Index
go
1
back.
value 2, index 3 value 20.
Index 2 value 20. We start the
Index
index
2
from
value.
0.
Yeah,
So
yeah,
till here it is working.
yeah. Okay.
Okay, once we have done with this, okay. So there is some differences between
Pointer and reference.
pointer and the references. Okay. So 1 second, I think some of my voice is getting break a little. I need to plug the charger in. Just give me 1 second.
So no problem. Okay.
It's fine now. Okay, so till where we have started. Okay, I will just make it into this view. Okay, so basic pointers store address of a variable. Okay, so
Okay.
store the address of the variable where it is an alias name of existing variable. So what we can do is, see now here the size is not mentioned. Okay, so what is the size of reference variable we can check. Let's
Okay.
go to it, come back, try to edit it, and we'll try to print the value of the reference 1, reference 2. What we use for getting the size of a variable,
Size of
size of operator.
yeah.
Okay, so we have a reference 1. Okay,
Reference 1, reference 2.
so let's take handle first, otherwise it will be confusing.
Sure.
Okay, so we'll have reference 1, we have reference 2, we have, and ref we have
And ref. Okay. Reference
2
2 and ref.
and ref. We'll see how what is the size.
Sure.
Control X, yes, enter, we'll compile it.
Four 820.
Okay, why 4820? Any guesses?
Yeah. First one
At least
4 bytes. First one 4
first one is holding what?
int value.
Integers. Second one holding was pointer.
Into pointer.
Yes. Third one holding what?
Pointer.
Array.
Reference value. Array, yes, array.
See. First one is
Array
holding what?
the 5.
First one is holding an integer int. So int
Yes.
size is 4
4
bytes.
bytes. Yeah.
At pointer size is 8 byte. Any pointer you take,
8.
this is 8 only. And
Okay.
array
Okay.
size is
Array size is 5. 5 into 4, 20.
yes. So that is the size.
Yes. Got it.
So what value it is holding, that is. So one more point you can add into this is size of reference. Okay. So
Okay.
okay. So it is holding the address and it is holding the existing variable.
Okay.
Okay. Initialization, pointer can be
Okay.
initialized at any point of time. For example,
Okay.
if we go into this one and we are having this PTR. PTR is pointing to this one,
Refer to.
variable second. We can change
Yes.
the PTR to, see here it is pointing to this one, right? If we convert
Yes.
it to 1 also, we can do that. Okay, but in the reference point, we cannot do this. Once we have initialized this, suppose we have initialized over here and we have initialized over here. So you cannot change this particular. You cannot
Okay.
write it where to. Here you can write where to first time. But if same I did it again, copy it, I come over here, paste it, and I write it as 2.
Initialize it in one time only.
Yes, see what is showing?
Yeah, it's showing redeclaration of int and ref1.
Yes, the second point
Previous-
determines this. So while we are what we are doing?
Yeah.
We are redeclaring this reference variable. This is not allowed.
Yeah.
Pointer can be reinitialized.
Reinitialized. Okay.
Yes, variable can be reinitialized, but reference variable cannot be reinitialized.
Cannot be reinitialized.
Okay, null allowed. So
Yes,
you can
fine.
you can put reference variable as a null, but you cannot. Sorry, you can put a pointer as a null, but you cannot put a reference variable as a null. Okay, reassignment.
Yes.
Just now we have seen it. This point and
And
this
point to
point is there.
different variable.
Okay, there is this point has a little more interesting. So you cannot have single this one also. For example, you declare this one like this.
Yes.
This is not allowed.
Okay. Okay.
So see, it will say
Yeah.
it will
Yeah.
error. Declare as reference but not initialize. So when we are declaring
Initialize.
reference, we always need to
Then
always need to initialize.
when it's created, then it reinitialized.
Saying that must be initialized. Yeah, this point.
Yes, must be initialized at declaration. Yes.
Okay. Whereas integer can be initialized anywhere.
Anyway.
Reassignment, it can reassign everywhere. It cannot change to reference. Once it is referred, it cannot be changed. It cannot be referred to null. Whereas pointer, we mostly, when we assign a pointer, we always put it to null. Why we put it to null?
Null pointer is there.
Null is the constant we are giving it to it. Null is we assign normally pointer with the initial value to the null, so that it don't point to any unknown position, and when we try to dereference it and create a problem. That's why whenever you are assigning a pointer which you want to reassign later, that we put it as null. Otherwise, it is a wild pointer. Wild pointer pointing to an unwanted location.
Uninitialized. Unwanted. Oh yes.
Okay. Memory uses. Let's try. So it occupies the memory address. It doesn't usually not have any memory. But the point is why it is showing 4. 4 it is showing, 8 it is showing 20.
Oh.
Correct? Why it is showing like this? because it
Yes,
is
yes.
pointing to that integer array and other things. So it is giving the size of those which variable it is
Yeah.
referring. It is not giving its own size.
Okay.
Okay, so no extra memory is used.
Yes.
Okay, so let syntax we have already seen. Dereferencing is
Yes.
required. Here dereferencing is not required because it is same thing. Although we
Okay.
have dereferences using a pointer, but that is also not, that is a re-referencing for the getting the value. Holds the address of the variable, has no independent address, same as variable. So we put it as the same as the variable. So we can have
Okay.
two-dimensional pointer, three-dimensional pointer, but there is no multiple level of references.
Okay.
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 Arithmetic
Oh,
arithmetic supports we
okay.
give. So what the sort of arithmetic support we give? Plus plus. If we add, for example, we
Minus.
point the pointer to an array and we give it a plus plus, so it can move, but there is no arithmetic allowed over here.
Okay.
Use cases: dynamic memory allocation for pointers, array, data structures, function pointers. There are so many use cases. For example, creating your own linked list and all, we use pointers. Whereas it is used for the function parameters. The reference value can be
Okay.
used for function parameters, operator overloading, and reference to multiple values. Return the multiple
Uh,
values. Okay, so
Return
for this
multiple.
point, okay, so for this point, last point, we'll create a
Okay.
program. Okay, so what it is mean is, let's create another program,
Okay.
nano 2.cpp. Include iostream. Okay, using name base std int main. Okay, so we'll create a swapping program. Swap.
Swapping program.
What it will take? It will take
We'll
x, which
say
is 5,
okay.
int y, which is
One.
okay.
10.
Okay,
10.
now we will send x comma y.
1.
Okay, so this is our first function. We create another function. This is, we can say, normal swap. Okay, so and other will say ref underscore swap.
And
X comma.
X comma.
Okay. Sorry.
And X and Y.
No, we don't need to give x and over here. We'll take
Okay.
x from.
Okay.
Then we'll have pointer swap x comma y. Here for pointers, here we need to pass the references.
References.
Okay, so understand this, what we are passing over here. Okay,
Yeah.
it is not our data type,
Yeah.
it is the values we are passing. So here what we are passing the
Right.
address of x and address of y. Here in normal swell we are
Of Y.
passing the
Yes.
actual values. Here what we are passing, here also we are passing the actual values, but
X and
there
Y.
we will collect with the
Okay.
help of reference. Okay, now
Reference.
we will printing this also.
Reference.
Okay, every time we pass, we'll print the value of x and y. X equals to y equals to, sorry, x, and we have a space we need it, y equals to y and dl. Okay, now we'll make the functions. Now, what type of approach we are using? Shankar, what type
Yeah.
of approach? What type of approach we are using? Top to bottom, bottom to top.
Bottom to top.
No, this we are making main function, and we are writing sub function.
Bottom
Top
to
to
top.
top to bottom.
Top to bottom. Top to bottom.
Main function is the top now. Then it will call the normal
Yeah.
function. Then it will call the reference function. Then we call
Top to
it.
bottom.
Till now we are doing the procedural programming only. We have not gone to the object programming. Okay, so
Okay.
I will write this first function. So it is not returning any type. So first function will be not returnable. So it will be void. What it is taking? It is taking two variable int x,
X
comma
into y. Into y.
Okay, now we will have a swap function. What this swap function will do, we will have an integer temp value. Temp value will take x. X value will take y.
Temp.
Y value will take temp. This is done. We'll copy it,
X.
make some change
X
into it, and
equals to y.
okay. Now here he will taking the reference.
Y equals to 10.
Same only. No need to change anything. Just need to change over here. Okay, next. Now here we need to change. So here we are taking as this will be as a pointers. Okay. So we'll need to make the star on everywhere.
Yes.
Okay. Control X. Yes. Now we'll have GCC. GCC is the compiler we are using. So it comes built in when you are using a Linux. Otherwise, you need to download MinGW and set up yourself using
Okay.
VS Code or something, or you can directly go into online and write CCP. This one, GNU G or you can write simply as a C++ compiler. Swap is okay. I have not changed the function names. Using the same function name actually. My bad.
Online computer. Okay.
I'm using this Nano. You can use Vim also. But I like this a little because it is just like a normal Windows editor. It is also free inside a Linux if you don't need to download anything as well. Reference swap. Okay. This is pointer.
Pointer swap. Reference swap.
I think it's done. Let's check out.
Yeah.
Don't declare why it is not declared. Okay.
Yeah. Normal swap.
Okay. So you can see in the first time X value or Y value should change. What's going on?
Yeah.
So you can say 1 second. I think one is key. Give me a second. It's asking for where is that? Okay. Hi Pavan. Got a little late.
Yeah.
Okay, so today we have just quick revision for you. So actually we are discussing the basic principles. Okay, so when C++ started and all those things. So I'll give you a quick review, 5 minute quick revision. Okay, I think you already know this, but okay. So we have discussed about the starting of C++. C++ started by the developed by the Bran. Okay, it is developed in starting version comes in 1979, and it is named as C plus C plus C with classes. Okay, in 1983, he written the first version of C plus plus. Okay, some features like C plus plus, Java is also written in C plus plus. Some features we have seen that C++ is a middle level language, which means that it can write an application code as well as the bit level code as well. So it can deal with the hardware as well as, and it can solve the complexity of an application layer as well. So C supports OOPS concept. It supports generic programming and templates. Okay, so some differences. I will share this PPT. You can know. So see, already we have discussed about that. So reference variable we were discussing, and in this reference variable, some points we have discussed. So um, you know, till here, I think you know how to make a reference variable. Hello, hello, Pavan, are you there?
Yes.
Okay. So I think last time also we've discussed something about reference variable. Okay. So we are in the continuity of that. So for the syntax of a reference variable is this. So reference variable is like int a we have. Sorry. Okay. This is a syntax for every variable. For example, this is a syntax. We have an integer a with value 10. So to link the reference variable with our normal integer variable, this is a syntax to make it. And once this declaration you have done, then this a and this ref both having the same memory. So they are just the duplicate name of each other. Okay, reference variable do not create a separate memory. Okay, one more point, reference variable must be initialized when it's created. So here we need to do the initialization. We cannot do like this. Just we initialize it and we will use it later. This is wrong. This we cannot do. Okay. These points we have discussed, and we have discussed this thing also to syntax that that we can give a reference variable to a array name as well. Suppose this is an integer array of 5 elements, 1 2 3 4. So how is the syntax written for the reference variable? Suppose this is our reference variable. So we have taken this reference variable and this 5. As you know, the subscript operator has more precedency. Okay, so we need to cover it with this small brackets. So it tell that this token is different, this token is different. Now this is reference for the this is a reference for the array. So this sorry, this ARR and this REF both are the same name of the array. Any confusion in this? Hello.
No.
Okay, we have done some programs also. I will refer those programs also. So there are some differences between pointers and the reference variable. So you have any doubt in any of them? Let me know. Read it and find out if you have some doubt. It is visible to you, right?
Yes, it's visible.
Hmm. When you're done, just let me know.
No doubt, Devansh.
Okay, boy. Okay. Okay, so I think heading is not there or what? Okay. Next is scope resolution operator. Okay, what is scope resolution operator and why we used it? Okay. So four places we use the scope resolution operator. The scope resolution operator looks like this. Okay. First example, we are mainly using it. We'll see it. For example, defining a member function outside the class. I think we have done a program into it. So accessing the global variable when the local variable exists. Okay, for example, we make a program nano 3.cpp. Okay, suppose we have this. Okay, now we'll have something like this int main. Okay, inside this int main, I just have a bracket return return 0. So this main bracket is completed. Now see very carefully. Okay, so suppose I have written a block. So inside these curly braces I have a block. Okay, and here I have written int x is equals to 100. Okay, and here I have written int x is equals to 10. Okay, and see out x is equals to and okay, so what would be the output of this?
10.
Hello guys, 10. Why 10?
It's having X is having block scope.
Yes, correct. Okay, so suppose in the program I want this x is equals to 100 also. I don't want 10 over here. In next iteration I want this 100. So for that we can use scope resolution operator. We'll write x with scope, or we can write x with this. Okay, now what we'll write? Simple, x. See, I will not. Why it is showing issue? Oh, why it is showing issue? Hmm. 1 second, guys. Syntax wise, I will making some mistake. Okay, let's
Use close the bracket. You can use close the bracket. Here you have used open the two brackets. Oh, okay, it's correct.
globally will declare. We'll see this. Yeah. See, now it is coming, but it should come in this way also. I will see why it is not coming this way, but it should go. So now this. Oh yes. I have not closed the bracket. Correct. That's why it was not coming. One, two, one bracket, close bracket. We have one open bracket. Okay, I have not created a bracket. Yes, it's. Check it. It still is not making it. Okay, we'll see it. What's the problem? Might be this compiler having some issue. But as you can see now, so with the help of this scope resolution operator, we can see the global variable, not the local one. So we are seeing this global 100. Try to comment this one. Again, it's have a issue. Not taking it. Okay, let's move to the other part. So next is this one. So, yes. Access global variable, defining the function outside the class. Okay. Accessing the namespace members. Okay, so how we do this namespace members are like this. Third point I'm discussing. First point we have discussed. Second point also we'll discuss. First we'll discuss this one. Accessing the namespace member. So what it is means is, for example, this using namespace std. Okay. If I remove this namespace std, this namespace std has this cout object. Okay. So when this namespace std is removed, I'll just remove this also. Okay. So now we have removed this namespace std. The cout will not be working because this cout definition is written inside this namespace. Okay, let's try this. Build this. See, now it is telling that it's an error. We have to comment this one also. Okay, so what is the solution for this? So as we know, it is a part of namespace std. We can use something like this and this handle. Handle is also a part of namespace std only. What we are doing is we are using the object, same block inside it. So inside the std, cout is there. So we are saying this from this std namespace, find the cout and give us the solution. So dot/3. See, now it is working fine. Okay. Okay. A member function we have seen. I think both of you know what is a member function is. So we'll try to make a member function program also. Any doubt in this? Hello?
No.
Okay.
No.
Okay, we'll create a class. Class ABC. Capital letter for class. Open bracket, close bracket. Now we'll make public layout. We'll create a function void dis display. Okay, suppose this is a void display, and this I have declared inside, but I need to give the definition of this. So what I will do is ABC void return type, class name, and the scope resolution operator to telling that this display function belong to this class. Okay, now we have created the function. We need to create an object also. So we'll say ABC obj1. Okay, now we'll say obj1 dot display. Dot 4. See, so in this way also this point is there. Okay, so these 3 points we have discussed. What? Accessing the global variable when local variable access, defining a member function outside the class. So I have defined the member function. Which member function I have defined? Hello?
Display.
Display with the object.
Play.
Okay, and accessing the namespace member, we have accessed the namespace member, this one, this std. Okay, so next thing left is static member of the classes. So this we will be studying when we are studying the static member of the class. So it is like two concepts will be mixed. So I am just pointing it a star, and I will be explaining it when we are dealing with the static members and the static class. Static function and static members. Okay.
Yes.
Hello?
Okay.
Okay. Now we will be discussing about bool. Last topic of today. And there is one more point over this which I have not covered right now. That is making of our own namespaces. We will discuss it tomorrow. How to make our own namespaces, and it is a little lengthy concept. So we'll see the nested namespaces also. We'll do it tomorrow. But for today, till this, a basic introduction of scope resolution operator. Okay, now bool. Bool is a built-in data type. Okay, bool has two values, true or false. Typically, one byte storage it has, and it is only used for readability. Okay, so how you can write this? It is like this: bool. Okay, after bool you can write your name, for example, flag. Okay, and you can have put any condition, like a is greater than b or not. So if a is greater than b, it will return a flag to this. So it can be true or it can be false. The simple point of this bool thing is this one. Okay, so now our next topics will be strings. So it also required, actually it is a very large topic. It required almost like 2 days time, because it is a part of STL. Okay, so we're discussing it tomorrow. So, hello.
Clear.
Okay, so try to revise your string related concept in C. I mean this string star ptr equals to this one. What its properties are. Hello. Okay, how it is forming, how we can change it or not change it. What is the difference between this and this one? This is the C concepts. We have written something like this. Okay, what is the difference between both of them? Okay, or this is the second definition, and third you can have something like this: chr this one 10. Okay, and you can have something like this: 1 comma 2, something like this. Okay, so that's all. So try to revise all these concepts, because we will be studying tomorrow what is a C style strings. Okay, what is upgradation we have in the string class. Okay, then we will be studying what is a constructor type of how we are using the string in a constructor, capacity size. All of these are the methods of the string. So we're looking each and every method of it. I mean, one method of each and every one, because there are lots of methods. So we'll seeing each and every one of them. Okay, so this namespace part is also left. We'll see it tomorrow. Okay, any doubt till now?
No.
No.
Okay, then we will winding up. Oh, your assignment is today will be. I need this string related things. Okay, C string related programs you need to do in C only, not in C++. Try to make a string related questions, like finding a substring in a full string. Okay, iterating over the string. Some C related string question you will do. Okay, so I will give an example. For example, make like 4 questions, not more than that. 4 questions of string. What it will be in C? What it will be? It will like reverse the string. Reverse the string. Okay, suppose I have written like hello world. Hello I have written, so it should be like hello something. Okay, and okay, if I written hello world, then it should be like world hello. Okay, so 3 questions you have. First, try to reverse hello, then try to reverse the whole word. Hello world and world hello. And give me the time notation also. For example, what it is. It's a BGO of 1. I want to ask that you know about this concept. BGO of 1, this one. BGO of n,
No.
BGO of log n, log n. These all things you know what it is. Space-time complexity.
The time complexity.
You have heard about it?
Yes.
Yeah. So try to
Heard
do
about
it.
it.
Okay. So I think Sankar has not. So Sankar try to do it with a string related thing in C, and Pavan, you try to do it the same thing, but I want that you do in 2-3 manners and try to figure out which method is more time space complexity is less, and
Okay.
whichever function you are making, try to get its time space complexity.
Okay.
Okay, it's clear. Okay, then we'll meet tomorrow, same 5:30 time.